Have you ever wondered why a metal spoon heats up so quickly in a bowl of hot soup, while the soup cools down much more slowly? The answer is specific heat. Today, I'm going to explain what specific heat means and show you how to solve a simple problem using the specific heat equation. Let's start with the definition. Specific heat is the amount of heat energy needed to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. Let's break that definition into smaller pieces. First, 1 kilogram. Scientists use 1 kilogram as the standard amount so that we can compare different materials fairly. Second, raise the temperature by 1 degree Celsius. We are simply asking, how much energy does it take to make this material just 1 degree warmer? Different materials need different amounts of energy. Some materials heat up easily, while others require much more energy to increase their temperature. Now let's compare two materials. Imagine we have 1 kilogram of water and 1 kilogram of iron. We want to increase the temperature of both by exactly 1 degree Celsius. Will they need the same amount of heat energy? No. Water needs much more heat energy than iron. That means water has a higher specific heat. Iron heats up much more easily because it has a lower specific heat. Here's an easy way to remember it. High specific heat means more energy is needed to heat it up. Low specific heat means less energy is needed to heat it up. Let's look at two everyday examples. During the summer, the land becomes hot much faster than the ocean. Why? Because water has a high specific heat. It takes a lot of heat energy to increase the temperature of water. So the ocean warms up slowly. Place a metal spoon in a bowl of hot soup. After a short time, the spoon becomes hot. That's because metal has a much lower specific heat than water. It takes less energy to raise the spoon's temperature, so it heats up quickly. Now that we understand the idea of specific heat, let's solve a simple problem. To calculate heat energy, we use this equation. Q is the heat energy, M is the mass, C is the specific heat, delta T is the change in temperature. Let's try an example. The specific heat of water is 4,200 joules per kilogram per degree Celsius. How much heat energy is needed to raise the temperature of 2 kilograms of water from 20 degrees Celsius to 25 degrees Celsius? Now substitute these values into the equation. This means we need 42,000 joules of heat energy to raise the temperature of 2 kilograms of water by 5 degrees Celsius. Notice something important. If the mass is larger, you need more heat energy. If the temperature change is larger, you also need more heat energy. And if the material has a higher specific heat, more heat energy is required.